All right, so I'm gonna record a quick video here on sine law and do a better job of talking about the ambiguous case than I did in class yesterday, because it was a little unexpected. I didn't mean for it to come up, so I will make sure that question gets changed in the future. But we'll start from the beginning here and talk about really what's happening with this ambiguous case. So to recall sine law, we use it to solve when we have two angles and any side length. It helps us find a side length or if we have two sides and one of the angles are opposite of one of those two sides, we can use it to find an angle. And usually if we're trying to find an angle, we can use this equation here with our angles on top, because when they're on top it's easier to solve for than when it's in the bottom. Or if we're trying to find a side length, we can use this equation here. Because side lengths are on the top, the little lowercase letters makes it easier to solve that way. So example 1, we have triangle DEF, and we have an angle of 57 degrees. I will use a ruler this time. Learn my mistake from yesterday. 57 degrees, maybe something approximately like this. And we have, so that's angle E, 57 degrees. The side across from that is 12.3. I made this line too long. Side across from is 12.3. Put some white out on there. And our other side's 14.2. So across from angle E, we're going to have side E, which 12.3 centimeters. And across from our angle F, we'd have side F, which we're saying is 14.2 centimeters. So then we'll call this D. D and lowercase d. And we want to find angle D and find angle F. So we have this complete pair, angle C, side C. That means we can use sine law. We know one part of this pair, we just don't know angle F. So I can use sine of F over F equals sine of E over E, and really it's also equal to sine D over D, but we don't need to know anything about D here. Well, we don't know our angle F. We know side F is 14.2 centimeters. Our angle E is 57 degrees. Side E is 12.3 centimeters. We can take the unit. We don't need to add the units into our equation because it can make things more confusing. We would have to multiply by 14.2. And to get angle F, we need to take our sine inverse of that entire side here. So 14.2 gets multiplied in to get rid of it on the left side, and we take the sine inverse to get just our F. So putting this whole thing in our calculator, we get sine inverse is 14.2 sine 57 divided by 12.3. So I put all that in a big set of brackets, my sine inverse, and we get F is 75.5 degrees. Which that looks like it makes sense on the triangle we've drawn here. Maybe I'll add this in a different color. 75.5 degrees, my angle F. Now, one of the things that we talked about yesterday is because of the cast rule, I have sine is positive in that quadrant, and every angle is positive in this quadrant. And so one of the things that we've been talking about, we focused on it from a special triangle perspective, but if I have the same related acute angle, sine of those two angles is going to be exactly equal to each other. So if this is 75.5 degrees, that means that if I had a 75.5 degree angle here, I would get the exact same triangle on both sides of our Cartesian plane. Oops. Where I have the same angle here and here. Sine was made up of a y value and an r value, and that y value is the same for both of those triangles. So sine of 75.5 degrees, this angle here, it has to be the same as the sine of this angle here, starting from our starting in our standard position from that initial arm. So this angle here, well, it's 75.5 degrees away from being at 180 degrees. So 180 minus 75.5, we get 104.5. So these are both exactly equal to each other. And that means that they should both be equal to this, which really means I don't know if this is the right answer or if this is the right answer. And you might look and say, well, the triangle you drew, there's only one possible answer for that triangle. And that's where I tell you, maybe I'm just not good at drawing triangles. Because that 12.3, I don't have enough information to know that it's being drawn this way. If I draw my 14.2 the same direction, and I draw this D in the same direction, so I have an F equals 14.2 centimeters. I have this is 57 degrees, which that looks about the same as my other answer here. Can I draw this big enough? Now this also has the same side F. Oops, I need to zoom out a little bit. This has the same side F, 14.2 centimeters, 14.2 centimeters. So angle F, angle D, angle E, still have a 57 degree angle, but now that 12.3 centimeters, so that's slightly shorter than that 14.2, well, it's kind of swung all the way back. you kind of get that same shape. Either I could be 75.5 degrees here or 75.5 degrees here, meaning this angle here, that is the 104.5 degrees. And it might help maybe if I draw this a little bit more exaggerated here. Where I have a drawing that looks kind of like this, where I have two options for F. One with this as a 75.5 degree angle, and one with this as a 104.5 degree angle, where they both have the same angle E, the same side from D to F, whether it's this small triangle or this great big triangle. If I put sine of 75.5 in my calculator, 0.9681, it's the same as sine of 104.5. 0.9681, because of that symmetry with sine. So that's the ambiguous case, where we don't have enough information to know which case. Do I have this triangle, DEF, or do I have this great big DEF? So I need to consider both of these options. If I have the angle 75.5 degrees here, well, my D is going to equal 180 minus our 57 degrees minus our 75.5 degrees. And we get 47.5. Or if angle F was 104.5, well, we can do the same thing. 180 minus 57 minus our F. This time it's 104.5. And we get 180 minus 57 minus 104.5. My calculator likes to give mixed fractions. 18.5 degrees. So really all we can answer this question with is either F equals 75.5 degrees and D equals 47.5 degrees, or F equals 104.5 degrees and D equals 18.5 degrees. Both of these work for the triangle that we have. And it depends, are we looking at this big angle D, or are we looking at this smaller angle D? Are we looking at this angle F or this angle F or this angle F? We don't know. We have two options. And that's why it's ambiguous. Ambiguous just means it's unclear. So we'll move on to this triangle here, angle ABC, and we'll see what happens here. So again, we can start with our angle. This one's a lot bigger, 72.3 degrees. I'll draw it out. 72.5. And we'll start with just solving it how we've been doing. 72.5, that's our angle A. We can call this side B. 47.3 centimeters. And we'll try this. 35.2. That's our side A. So this is angle B, this is angle C. Same thing. If we're looking for angle B, well, we know everything about this pair. We can use sine law. Oops, sine of angle B over side B is equal to sine of angle A over side A. We don't care about C. We don't know anything about C. We don't need to for this one. Plug in what we know, 47.3. Our angle 72.3. Our side 35.2. Can multiply and take the inverse of everything. So multiply by 47.3. Take the sine of everything to get rid of the sine from this side, sorry, sine inverse of everything, and we'll plug that in our calculator and see. 47.3 times sine of 72.3 divided by 35.2. Another option on your calculator, you have this answer button. I need to take the sine inverse of everything of that previous answer. Uh-oh, math error. Let's go back. Oh, it won't let me go back. Okay, we'll type this in again. 47.3 sine 72.3 divided by 35.2. We got an error because it's not, if we're doing the sine inverse, this means that this is my opposite and hypotenuse sides. I can't have a ratio of those sides be bigger than 1. I can't have my opposite side be bigger than my hypotenuse. So we got an error. It's not possible. This triangle is not possible. Why? Why is that? This side is too long. That really my 35.2, it's not possible to get down to an angle of 72.3 degrees. We have a side that's too short. It's never going to meet here. This side B was far too long. I know this is not completely to scale, but this arm here, no matter which way we turn it, it can't possibly get down all far enough to make a 72.3 degree angle. So we got a math error in the calculator. That's telling us that this triangle is not possible. So we saw a scenario where we had 2 possible answers, and we also saw a scenario where we had no possible answers. We're going to flip over here and look out another one here. Same thing. Can draw the angle. I'll keep it the same orientation just to be consistent. 37.3 degrees. So that's going to be our angle A. Make this a little bit bigger. 19.3 centimeters. And ooh, that's way too big. Oh no. Try this again. 72.4 is enormous. So I need to shorten this side up a little bit to at least make it make sense. Or have it, yeah, try to appear like something that would make sense. So 72.3, that's way, 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 way bigger. Maybe I'll draw something out like this. All right. So A was 72.4 centimeters. And this will be our B, 19.3 centimeters. Which means here's going to be our angle C. Right here. ABC. So we'll do the exact same thing. We're looking for angle B. So we'll put angle B on the top. I know everything about the angle side pair A. So that'll be the other one we'll use. Again, C we don't need here. You might see a pattern where we keep multiplying by that bottom value, and then we take the sine inverse. So we could preemptively do that before we plug numbers in, rearrange for B, if you find that nice to deal with just variables before you plug numbers in. If you want to do it like we did here, you're allowed to do that as well. Plug in your numbers and solve after the fact. Either way works. I will plug in our numbers, 19.3 sine 37.3 degrees, all over 72.4. Sine inverse equals our angle B. So sine inverse of 19.3 times sine 37.3 divided by 72.4 equals 9.3 degrees. So it's saying that this angle is so small, it's only 9.3 degrees. Well, we know from what we talked about on here that there should be another side bigger than 90 degrees that's the same as sine of 9.3 degrees. And again, they should have the same related acute angle. So it should be 180 minus that 9.3 degrees. So this should be the same as sine of 170.7 degrees. Now here, it's saying both of these angles work for our trig ratios. But 170 degrees, that's not possible if I already have an angle of 37 degrees. So that doesn't make sense for our triangle here. And really what it means is if this angle is moved all the way back around until it can meet back up with, or this 72.4 degree arm, it's moved all the way around until it meets back up with this angle here again. Well, it would be past this triangle. We get a case where we have one triangle like this, and to get the exact same angle, we'd have to have that arm move all the way out this way to get that same angle. And that's going to mean we no longer would have this 37.3 degree angle. This triangle here would use a completely different angle here. So that would break the rules of what we were told. This one's not ambiguous. This only has this way doesn't make sense for this triangle. So the only possible answer is having 9.3 degrees. Based on what they've told us of these three sides, or these two sides in this angle. So it turns out there's three possibilities. We could have zero angles. We could have one possible angle. We could have one possible, or two possible angles in these triangles. So to decipher which scenario we have, we want to go about normally, see if we get an answer, because when we have zero possible triangles, we got a math error. And if we have an answer, check what other angle gives you the same sine ratio? So 180 minus this angle. We did 180 minus this angle. And see if that second angle makes sense. Here, it didn't make sense. I can't have this angle and this angle in my triangle, because that's already past 180 degrees. Here, well, this angle and this angle did work. There was still enough left for angle D. This angle and this angle worked, so we had the two distinct possibilities. So we can have either 0 triangles, 1 triangle, or 2 triangle, and this occurs when we know an angle side of a triangle. What happened yesterday, and do I have, yes, I have the notes here, is when we were solving this triangle using the sine law, we had everything about A, and then we also knew our side B. So we knew angle side. Yeah, we knew angle side. We ignored this C in our problem, and that was part of how we ended up with this scenario of us having the two different possibilities. Now this C actually helped us narrow it down where it could only be the one possibility. It ended up being that, well, we had a larger than 90-degree angle here. Cosine law yesterday would have just given us one possibility, because cosine, it matters whether it's positive cosine or negative cosine. Sine, it can be positive in both, and that's how we get this ambiguous case. And that's part of why we did the cast stuff first, is it helps with this scenario to kind of explain what is happening. I'm going to post a video as well. Let me know if you have any questions, and I will be online from 1:30 until 2:30 on a Google Meet if anybody does need any assistance. Enjoy your blended learning day, and we'll see you tomorrow for some word problems.